Hey everyone, today we're going to look at a mechanical advantage problem. You'll likely see this on a deck gen exam. When a weight of 800 pounds is suspended, what is the stress on the hauling part when using a gun tackle rove to least advantage? So step one is to write your givens. I've done that below. Our weight is 800 pounds and our mechanical advantage is 2. Now, how do I know that? I've referenced this US Coast Guard diagram and I filled in by memory what the mechanical advantage is and the names of each of these are. So if the line points down, that is just counting the number of sheaves for the mechanical advantage. The line's pointing down and the twofold purchase has 4 sheaves. The mechanical advantage is 4. If the line points up, you add 1 for that mechanical advantage. So the number of sheaves plus 1. That twofold purchase rove to advantage, or the line pointing up, is 2 sheaves plus 1 for a mechanical advantage of 5. Now if we look at the gun tackle, there's 2 sheaves, 1 on the bottom, 1 on the top. We're rove to least advantage as noted in the problem. So that mechanical advantage is going to be 2. If this was rove to advantage, we'd look at the 2 sheave gun tackle below, line pointing up, 2 sheaves plus 1 for mechanical advantage of 3. So looking at a gun tackle rove to least advantage, mechanical advantage is 2. So step 3 is to plug it into our equation and solve. Here's our equation here. Our stress equals weight over our mechanical advantage. So what that's going to look like is our stress equals our weight of 800 pounds divided by our mechanical advantage of 2 for a stress of 400 pounds. Now there are other problems like this that note in the question whether to add 10% for friction per sheave. In this question it does not, so we don't need to do that. But I do have a problem that has that stipulation and I'll link it down below.